Good morning, boys and girls. We have a science lesson today on heat and light energy again, and we're going to be talking about light and objects, how light interacts with objects, including reflections and refractions, how images start to change based off of what object the light is hitting, and also on different types of objects, how light travels through them. So let's begin page 14 over here. So reading from this heat and light energy book. Now light moves away from a light source in a straight line until it hits an object. We've seen that in our experiment from Friday. If you did the one with the index cards, light traveling in a straight line through those holes. But what happens once it actually hits the object, something blocking that light? That depends on the material the object is made of. Now, transparent materials allow nearly all light to pass through them. Clear window glass is transparent. So almost all of the energy from the sun travels through just that plain window pane, the glass. Here's a thing of Germex here with a transparent plastic as well. The light would travel through that transparent and the transparency of that object as well. Now, something that is translucent. Okay, so we've got transparent and translucent. Translucent materials allow some light to pass through, but we cannot see through them clearly. Frosted glass is an example of something translucent. Some of you might have that like as your shower door at home, at that type of frosted glass. Also, something that's more of like a colored plastic like this, that's kind of muted, does not allow all light to come through. As you can see, more of the plain white light passes through a translucent object versus a transparent object. Even my hand, you can see a shadow of it behind, but you can't see it as clearly as you would through a window. Now, an opaque material does not allow any light waves to pass through. Opaque. Wood and metal are opaque. Light that strikes an opaque object is blocked. A shadow forms behind the object. So books would be an example of this, a computer that I'm using right now, our desks, materials for a house like brick and wood. Those are opaque objects. So if light is hitting that object, a shadow forms behind it. Now, absorption happens when light waves are taken in or absorbed by an object. Most objects absorb some light, even a translucent object would. Dark-colored objects absorb more light than light-colored objects. Light energy that is absorbed changes to thermal energy, and that is where we get heat. Dark pavement gets hot on a sunny day because it absorbs a lot of light. So if on a hot summer day, you've got an option between a black shirt and a white shirt to wear, you'd want to choose the white shirt because there's less light being absorbed. So it's not going to make you as hot as wearing a black shirt. That's going to absorb a lot of light and it's going to change to that thermal energy. So it's actually going to make you hotter. But on a cold, sunny day, you might want to use the black to make use of that light energy changing to thermal. Now, some of the light that strikes an object is not absorbed. Reflection happens when light waves bounce off an object. A mirror is smooth and shiny. It reflects a lot of light. Light waves that strike a flat mirror bounce off it at the same angle they strike it. A clear image can be seen. Objects such as rocks and trees also reflect some light. Obviously not nearly as much though. But an image does not form. That's because light waves bounce off in many directions as well. So once again, a rock or a tree is bumpy, those two objects. And so if light gets reflected, it ends up going in lots of different places. Whereas a mirror is so smooth and shiny. I've got one right here. And just like a little makeup product. So it's so clear and shiny that you're able to see exactly where the light rays hit bounce back. You can see the rest of the classroom there. So a mirror shows reflection perfectly. Other objects also do reflect light though. Now finally, refraction. Light can bend as it passes through different transparent or translucent materials. Refraction is the bending of light, the bending of light waves. Refraction happens because light waves move at different speeds through different materials. For example, light moves faster through the air than water. We heard about that, that light moves faster than any other energy, and it moves faster in open air, almost as fast as it would a vacuum in space. Moving in water is quite a bit slower. Now, when light waves move from one material to another, the change in speed can cause the waves to bend. This picture shows a great example of that refraction. It looks like it's broken up altogether. And it's because light is traveling fastest in this open air. And then in that transparent part right there, it moves slightly slower. In the water, it moves the slowest of all. And so the reflection that we're seeing is different than the one that's from just open air. It says, refraction makes this pencil look like it is in two pieces. Light waves move at different speeds through the water, glass, and air. Okay, so in this little caption says, a clear image forms when light waves reflect off the surface of a mirror. Look at that cute little kitty looking at his reflection. So I want you to look around your house and think through what you might have that is translucent, meaning totally clear, letting a lot of light in. Did I say translucent? Sorry. Transparent is the one that is clear, letting a lot of light in like a window. Translucent is a little foggy. You can see just a hint of that light coming through, but not all of it. And opaque, not letting any light through. Okay, so I want you to look for that. And I'd also love if you've got the ability at home to try out some refraction by filling up a glass and putting a straw in, filling up a glass with water and putting a straw in or something like that. It should be a transparent glass so that you can very easily see what's put inside. So if you have a straw or a spoon or something like that, you'll be able to see where it bends because of light moving in a different direction. So I'd love for you to do that as soon as you're done with this video. Also, as soon as you're done with this video, you do have a couple of notes to take. So I'll have that posted in Bright Thinker for you. I'll see you soon in class. I'm filming this in the morning. So I'll talk to you soon. Have a wonderful day. Bye.